Hi all, hope all is well. On today's very short video, I wanted to quickly touch upon some observations that I have made during the running of my solar still experiments. But before that, I wanted to quickly provide an overview of the process for new viewers. The solar distillation example in the following video occurs by placing a small jar filled with seawater inside a larger sealed jar like a Russian doll. The jars are then placed in the sun and the light and heat evaporates the water out of the center jar, resulting in the atmosphere of the larger jar to fill with moisture saturated air. During the night, the air cools and the moisture condensates out of the atmosphere of the larger jar, resulting in water collecting in the bottom of the larger jar. That's the basics. So now that everyone is on the same page, let's have a look at the following footage. The following footage contains footage captured during the running of two different variations of the experiments. One of the variations, seen in this footage, shows that the jars are taped shut to seal the atmosphere inside. By doing this, I was hoping to prohibit leakage. But look closely. The observation I am making in this footage is that the jar on the right, the jar that has charcoal in it, is clear. There is very little condensation forming on the inside. However, the control unit, the jar set up on the left, is showing massive amounts of condensation forming on the inside wall of the large jar. So just to make it simple, the observation I am making is that when the units are sealed tight, the charcoal variation is clear, while the control unit, the standard unit, is showing massive signs of condensation. Now let's watch what happens when the tape is removed. Removing the tape results in the charcoal unit to show massive amounts of condensation, while the control unit shows very little condensation. It's the complete opposite. So my question is, why is this happening? Considering that the only difference I am making is sealing the units compared to allowing the units to breathe, if the units are sealed, the charcoal unit remains clear, while the control unit condenses. If the units are allowed to breathe, the charcoal unit condenses and the control unit remains relatively clear. There is a very prominent difference between the two examples of the experiments. So, what's causing this? Something is clearly happening, and at this stage, all I have are speculations. But if I had to make a guess, I would contribute the differences to a mixture of thermodynamics, gas properties, and pressure variables. Perhaps by allowing the systems to breathe, no tape, the pressure is free to escape during the day, allowing for a partial vacuum to form at night. And perhaps this vacuum is working to benefit the coal variation system due to the extra heat retention of the charcoal itself, or perhaps it is due to the heat retention itself that directly results in greater pressure in the jar during the day. And by taping the unit shut, we are no longer allowing this pressure to escape, which is resulting in lower condensation. There is clearly a relationship between pressure, heat, and the charcoal. The only spanner in the works is the following. Taping the unit shut is also resulting in more condensation to occur in the unit with no charcoal, while stifling the condensation in the charcoal variation itself. Simply put, sealing the units is promoting condensation in the standard unit while prohibiting condensation in the charcoal unit. To put things even more simply, let's list the attributes of the taped system. The charcoal system is taped shut, has increased heat due to the presence of the charcoal, and increased pressure, which is resulting in less condensation to occur. The standard unit is sealed, has less heat compared to the charcoal unit, while having a lower pressure than the charcoal unit as well, due to the heat being lower due to the absence of the charcoal. This ultimately results in better condensation. Whereas with the breathable units, which potentially have partial vacuums, perhaps it is this vacuum that is drawing moisture into the unit from outside the system. Think about it like this. During the day, the non-sealed charcoal unit heats up, extrudes the atmosphere due to increased pressure. As the pressure balances with the atmospheric pressure outside the jar, this results in lower temp in the jar, resulting in more condensation to form. At night, when it cools, the atmosphere inside the jar loses temp, literally condensing, resulting in a partial vacuum to form. This vacuum is perhaps drawing atmosphere in from outside the jar, and inside this atmosphere is even more moisture, which could then be captured. If you are confused, rest assured you are not alone. If I can better understand exactly what's happening here, perhaps I can hijack the process to further speed up the process and improve the solar distillation process. Perhaps creating a system that encourages a partial vacuum to occur is part of the answer to improving the rate of solar distillation. And that's it for today's video. If you got anything of value out of this video, please feel free to give it a thumbs up. Please subscribe, and until next time, thanks for watching. Cheers. Bye.